LeetCode 54, spiral matrix in JavaScript. This is a messy problem. It's got 4 pointers and 4 functions that update those pointers. Each function that updates the pointer also has to keep track of where it is along the position for that pointer. It's messy, and I'll get into it. I have a demo that goes along with it, and that'll be on my website as well. So the matrix, give it an m by n matrix, return all the elements in spiral order. Our matrix is a 2D array. That's row 0, row 1, row 2. We have to return the spiral order as a single dimensional array. So we go across the first row, and then we're going to go down the remainder of the last call to the last row. We're going to decrement our call pointer, last call pointer at that point, and then we're going to traverse the row in reverse, decrement the row pointer before we do that, and that's going to be 8 and 7. Then we're going to traverse the column in reverse, and then we're going to increment the first call pointer, and then we're going to start all over again with our row, traverse the row in order, and increment our first row pointer, at which point the first row pointer will be pointing to 2, and our last row pointer will be pointing to 2, and there will be no more pointers. There will be no more rows or columns to iterate over, and because we know that because the pointers overlap. The demo showcases that. Now, the demo I have here right now shows an extra row. It's got an extra column. So if we get rid of that extra column, we can see it'll have the same visual layout. We have 3 rows and 3 columns. Now the numbers inside the cells are different. 1, 2, 3, 5, 6, 7, 9, 10, 11. The indices of the rows and columns are the same. 3 rows, 3 columns, 9 cells. We know this from basic geometry. Our last call pointer is 3. There's 3 columns, and the last call pointer will point to beyond the last column. So we have 0, 1, 2. So 3 columns. And our last row pointer is also 3. That points to beyond the last row. The first row pointer starts at 1. Now I said earlier that we go across the row, go down, go the row in reverse, traverse the call in reverse, and then traverse the last row. It's actually a little different. I actually started out by repopulating the first row. And the reason I did that is we can see that in our matrix, our first row corresponds to the first 3 things in that matrix. So I thought, well, why not just populate the result with our first row? And that's what I did. You can see where this destructuring statement here. So the spread operator, sorry. So we have our 3 rows, 3 columns. Now when we step, we're going to see that this first row is going to be traversed, and that's already actually done. And then the last call pointer decrements. So now our last call is 2. We're going to traverse down the last call. We're going to put the last 2 cells in those corresponding rows in our into our result. We step that, and we get the last 2. Now we're going to step through the last row, which we just decremented. You saw that decrement automatically when I click the step button. And we're going to go to the first call, and that's not going to change. All these pointers will stay the same now. And we go to the first column. And we're going to traverse up the first column in reverse. And that first column pointer is going to increment by 1. And finally, we do the last row, or the first row, which is our last row to traverse. And we'll know that because when we're done with that, the value is 2. The first row and the last row have the same value. And when that happens, there's nothing more to traverse. We're done. And as you saw earlier, we can have this with any number of rows and columns in the demo. So we can go across and go to the 4, and it pulls them right from the DOM. You see these are now 3, and the last row is 3, 0, 1, 2, 3, and this will go down to 2. And then it'll traverse across to our first call, which stays at 0. And then it goes up to our first row. And the column increments. And then we traverse across the first row, and that will increment to 2. And so that happens based by reading off of the DOM. And I made this demo to showcase how it works. And the reason for that is that it's so messy with the 4 pointers and with the loop through each pointer from one pointer to another pointer, and the loop having to change its incrementing variable like I or J for each case, that it just got too messy to try to explain. And so the best way to showcase it is with an actual physical demo. I'm going to put that on my website. But here's the code. We start out, we've got our pointers right here. Last call, last row, first call. And then we've got a cur pointer. That's our cursor. And that shows where we're at in our result. We don't need that. We could use array.prototype.push, but I chose to use a cur property because I thought I would pre-populate the length of the array. So we start out by populating the array with the first row. So our result right away has, from example 1, 1, 2, 3, and it'll have that from the start. And our cur property will point to the last call, which would be index 3, 0, 1, 2, 3. So it would point to that. That's where it's going to be at. That's where our cursor is going to be at for our output, for our result. The result's length is the length of the array, and we multiply that by the last row. So again, rows by columns indicates the number of cells. 3 by 3 is 9. We've got our 4 functions: traverse row, traverse row reverse, and traverse call reverse. And we set this up in the loop. Remember, we already traversed the first row by pre-populating that result. The way we're going to traverse the rest of them is we're going to start with a column, and we're going to check to see if the first call and the last call are equal. And the reason for that is, well, if you think about it, if we had a 1-column grid, and we go, and the last call is going to be 1 because that's the length of the columns. Then the length of the columns is shown up here, matrix 0.length. We have a row with length 1. Okay, so in that case, we'd have a row with length 1. So that would be 1. And then as soon as we traverse the first row and we had to go down, then it would decrement that. So traverse call, last call will go minus minus, and then it will become 0. And so you think about it. After we traverse call, we go minus minus calls. And if the first call and the last call are the same, and in this case, they're both 0, this hypothetical example I'm thinking of, then we'd be done. We'd be all done with that. And you can think about that even in an example here if you want to think about how that would work. You can showcase that. And I've never done this. This is the first time I've shown, even tried testing with 1 column in our demo. But this is how that should work. And hopefully it does. Our last row is 3, and the last call is 1. Well, go this row 1 should highlight 1. Okay, it does. Last call goes down to 0. Now it should go down. Last row should go down to 2. And since the last column is done, well, there's nothing more to do, so we're already done. So that's what would happen in that case. So back to this example. If the first column, and then the last column are the same, right? We already got the row, and then we go the column, just as we did in our demo here. We did the row that was pre-populated. It's a little different in the demo. We have to click step to see it. And then we did the column, just like we see over here. We do this column, and if the first column and the last column, in this case they're both 0, then we would break. Okay, now back to the actual example 1. Okay, and just go back to thinking about that example for a second. Traverse row and reverse. So we traverse the row. That was pre-populated. We traversed the column. We got 6 and 9. All right, that would be the next 2 things we would get into there. And then we would get traverse row reverse. And that will give us 8 and 7 in here. And then we'll go from the last, from this row to the first column. And then we go from the first column up to the first row, which is 1. And then we go from our first row, which is 1, we traverse across that row to the last call. And then we're done. And that's how this function works. So like I said, it's a really messy function. But if you want something that's a little easier to start working with rows and columns and things like that with a grid, set yourself up a grid and then reverse the rows and the columns. So you could take 1, 2, 3, 4, 5, 6, 7, 8, 9, and you could display it as, we could have 1, 4, 7, 2, 5, 8, 3, 6, 9. Thinking about the row values like that. And the way to do that would be to switch around the I and the J variables. So once you start playing with that, you'll see how that's useful. Now, in the DOM, document object model, we have tables. And the practicality of this type of problem is that we can use the DOM to update values in the browser that the user can see and the user can interact with, as I've shown in this demo here. So there's actual practical value to this LeetCode problem in front-end programming. You can have as many rows and columns as you want in this table. So, and this is all updated dynamically. I'm going to leave this on my website so you guys can use it. Thanks for watching.